My name is Rahul, and I want to talk about prompt-driven infrastructure, starting AI services for scale and resiliency. Given the increased adoption of the AI, it is very important to make sure the infrastructure that those models run are also able to scale to the requirement. In here, I will be discussing about how you can scale and make your AI services highly available. The challenge that traditional AI infrastructure have: performance bottleneck, single point of failure, and the resource contention. So we before we solve the problem, we need to understand what are the different challenges that are very specific to the AI services. The first thing is that there is extreme variability in the traffic. Second is that the conversations are stateful, so we have to store some state. The third is that resource intensity. Some of the tasks require a lot more resource than the other, and then unexpected failure. The sorting solution that I want to propose is, instead of serving all the traffic from the single shard of the service, we can have the multiple shards of the services serving some percentage of the traffic, and then we can have the intelligent logic to route the traffic and also fail over in case of any failure. Okay, so I would want to talk about some basic component. The first is the AI service chart, which means that we will be having the multiple charts of the services, each working independently. The metadata service, which is very important. This is the service which actually keeps track of all the charts we have and in their dependency. Since now we have the multiple charts, we also have to route the request to the chart that appropriate to that request. We also want our service to be sharded to the multiple availability zone, so that if there is an outage in one availability zone, the service is still be functional. The state management, since the conversation with the AI is stateful, so we have to take care of the state also. And then observability system. This becomes more important since we have multiple charts. So we have to have the correct observability to debug the issue. Okay. Yeah, want to go deep on some of this. So first one is that how we will maintain the session affinity, right? So we same request from the same user should go to the same shard every time, right? So that's where the intelligent metadata routing service come into the picture. It will have the affinity toward the shard which already serving the traffic. Second is that if the some shards are being overloaded, the routing need to be intelligent enough to route the traffic to the shards which have the less traffic. We can also have the priority based routing. This can have the multiple implementation based on the subscription model or based on the workload, the type of the workload, so many things. And also geographical optimization. So since we have multiple charts based on the different regions, so we can actually have the better routing to support it. So yeah, I think we need to talk about this, how we will be managing the state, since we already said that this conversations are stateful, there is context, there is some customer settings. So whenever we if the customer is already being served on one particular card and then for some reason we need to fail over to other, we also have to move the all the state responding to it, right? The one solution is that we can have the centralized database, which so what we are saying that we will have the multiple parts of the service running, but then they will have centralized database for the context, so that the computing is being started, but not the database, to be clear, right? The conversation migration. So if for some reason one shard is not working correctly, we have to communicate to that this conversation is being migrated to the other shard. So the process will first retrieve the state, we'll find out the new shard, we'll update the routing, and then and also we can do some pre-computing also. Okay, there are few different strategies that can be considered when we want to. So one thing is that we can have the more charts, which is horizontal scaling, right? Every time you want to scale, you can add more charts. The second one is that So if instead of one shard is like with handling more load, you can actually vertically scale it, right? The capacity reservation, this is we can reserve the host to adopt to the capacity. And the cost optimization, this is also if we use the reserved capacity, it will help in the cost optimization. The important thing is how can you auto scale, right? So there can be different indicator to the system that says that the system need to be scale up or they scale down. We will have a queue where we monitoring the customer request. If based on the queue size, we can decide to scale up or scale down the system. We will have the latency to serve the request based on some threshold. We can decide whether the if the requests are taking time, then we can scale up or scale down the system. Predictive models. These models are like the again AI model, which actually based on the past history of the usage, they predict the usage pattern and then so that we can up or scale down accordingly. The one more is the cost aware triggers, which will help you keep the cost in the check. If you have charts which are not being utilized, you can actually bring it down and then control the cost. Fault tolerance and resolution. Yeah. So since now we have multiple shards, it is very important to make sure they are all running fine. We can have the health check correspond to each shard. We can have the disaster recovery, automatic failover. These are the few things which we can do to make sure that the service always be available. So operational things, complexity and monitoring things. Now we have multiple charts. It's become very important to make sure that we are able to operate all the charts correctly. The most important thing is that if we have collecting all kind of metrics, we can actually build the automated system to monitor it and then make sure that all the systems are functional. The key benefit of using this approach is that you get close to 100% availability. You can scale your service as much as you want. There is a cost reduction because you don't have to maintain the monolithic system. You can actually customize this to if it need. So if it needs very basic resources, you can just have it so that you don't pay extra. And yeah, and each shard actually operates based on its own. So then there is like no dependency on each other. The implementation, so we have to first build few shards and then test it that your code is functional, and then you are able to scale up and scale down the shards. Your metadata service is working fine, and then you can actually explore the solution to the more shards. The future of AI infrastructure, I think the infrastructure becomes very important if we want to support this the increased demand of the AI. Have to make sure that the infrastructure is always available, and that's where the starting strategy will help. Thank you.